So welcome to our new topic in Level 2 NCEA Chemistry, Organic Chemistry. So let's begin. So in terms of organic chemistry, there are a number of terms that you have to know. For example, hydrocarbons, which are essentially compounds made only of hydrogen and carbon. The idea of a homologous series, which are compounds which have the same general formula, which we'll look at soon. Molecular formula, which shows the number of the atoms only. Structural formula shows how the atoms are actually arranged. The empirical formula shows the lowest whole number ratio of those atoms. The structural isomer is the same molecular formula, but this time different structures, which we'll look again in this lesson. The next lesson on alkanes. The empirical formula shows the lowest whole number ratio of the atoms in a molecule. And finally, functional groups, which we touched on when we looked at our wine internal, is the arrangement of atoms unique to the homologous series. So in terms of examples, this is an example here actually of an alkane, which we'll look at in the next video. The homologous series is 2NH2N plus 2, where N are whole numbers. Okay, so for the particular example, you've got N equals 4. The molecular formula therefore is C4H10, because 2N is 8 plus 2 is 10. Structural formula is there how it's arranged with all the single bonds shown, all the bonds shown between the carbons and hydrogens. And you can also do a condensed structural formula, which is seen there also, which is where you just write the letters involved with the atoms and don't put in the actual bond. And the empirical formula is C2H5, because C4H10 divided by 2 gives you C2H5. So in terms of a homologous series, which we touched on at the beginning, it's basically a general trend for all all molecules in the homologous series are an increase in boiling point and melting point, which again we'll look at when we look at the alkanes, alkenes, alcohols. This is because of the effect of intermolecular forces and molecular weights, which we'll touch on again when we look at the individual homologous series. And also the lengthening of the carbon chain, because as the carbon chains lengthen, then you're going to get more intermolecular forces between the associated molecules, harder to break, so it means that there's more energy required to break them apart to make them change state. And then structural isomers, you've got basically the same molecular formulas but different arrangements of those formulas. So you can either have branched, like we see here, or straight. And again, we'll look at that when we look at the alkanes in particular. And finally, these are the functional groups that we will look at in this particular unit, which you've already looked at some of them already when you did the wine internal. But alkanes, alkenes, and alkynes, which are kind of very similar, these slight differences. They're all hydrocarbons, only containing carbon and hydrogen. Then you've got amines and alcohols, carboxylic acids, which you looked at in your internal with the wine, and haloalkanes, which have a halogen bonded to the hydrocarbon. So let's begin our journey into the wonderful world of organic chemistry.